Hey guys, in this video we're going to talk about Chapter 3, Section 4, Quadratic Equations. So we talked a little bit about zeros in the last video. So the zeros of a quadratic function are the x-intercepts. Those two terms mean the same thing. And that's where the graph crosses the x-axis. So in this picture here we can see our zeros are at -1 and 2. And our zeros occur when y is equal to 0 because we don't have any vertical component here. So my 0 right here is going to be x equals 0, x equals 2, y equals 0, and on the left side x is equal to -1 and y is equal to 0. So we did some examples last time. We found the zeros by factoring, and so our function right here can be represented by the equation y equals x squared minus x minus 2. And since this is in standard form and a is equal to 1, we can factor this guy. So in our case, b is equal to -1 and c is equal to -2. And so we want to figure out what two numbers multiply to -2, but at the same time add to -1. And the answer there is -2 and +1. So our equation becomes, so originally we had this was x squared minus x minus 2. And when we factor it, we said that the two numbers that multiply to -2 and add to -1 are -2 and +1. Alright, so this guy is the same thing as this, it's just written in a different form. And to find the zeros, we set y equal to 0. And so in factored form, we have y is 0 equals x minus 2 times x plus 1. And the 0, we talked a little bit about the zero product property, kind of informally last time. It basically says if you have two things that are being multiplied together, either one of those things is 0 or both of those things are 0. So that's why we set each of these factors equal to 0, and we solve the equations. So adding 2 to both sides, we get x equals 2 on this one, and subtracting 1 from both sides, we get x equals -1 here. So these are the zeros, aka the x-intercepts, and we can see them right here in our graph. Alright, so let's do some more practice with factoring. Again, we're just looking at b and c, and we're trying to see what two numbers multiply to 18 and add to 11. And let's see, I'm thinking of 9 and 2. It's going to be +9 and +2 because both of these signs are positive. So in factored form, this is x plus 9 and x plus 2. To find the zeros, we set y equal to 0 and solve for x. So then I can set each of these guys equal to 0 and solve. So I can subtract 9 from both sides and get x equals -9. And I can subtract 2 from both sides to give me, to give me x equals -2. Alright, so those are my zeros. That's where the graph crosses the x-axis. So if we were to look at this, we would have a point here on Desmos. This would be -9, 0, right? X and y. And then we would have another point at -2, 0, right here. And remember, we can also find the vertex when we're in standard form, just like we have here. So the vertex, I'm not going to really do this, but remember that the vertex was h, k. And h was -b over 2a, and k was whatever we got when we plugged in -b over 2a into our function. So that's how we can get a little picture. We can also just punch this in Desmos and confirm that our zeros are indeed right here. Those are the x-intercepts. So, excellent. So we got the zeros there. Let's look at another problem. This time we have 1 again for A. We have -5 as B, and -24 is C. So what two numbers multiply to -24 but add to -5? Well, I know 8 minus 3 is 5, so I'm going to have something to do there with that. So the answer here is x minus 8, so -8, and then x plus 3, right? -8 plus 3 gives us -5, and also -8 times +3 gives us -24. All right, so we factored it, and once it's factored, we can set f of x equal to 0, which is y, basically. And from here, we can set each individual factor equal to 0. So x minus 8 equals 0, and x plus 3 equals 0. Add 8 to both sides to give me x equals 8. Subtract 3 from both sides to give me x equals -3. And those are my zeros. Those are my x-intercepts. All right, let's look at number 3. So this time our variable is s. And we see that A is 1, so it looks like, we could be in a good position to factor this. Sometimes we won't be able to factor this, but, a problem like this, but we're going to talk about how to do that in a few slides. So, what two numbers multiply to -30, yet add to -7? Well, 10 and 3 make 7. So it's going to be -10 and +3. So we have s -10, s +3. These two numbers multiply to -30, and at the same time, when you add them together, you get -7. So those are the missing numbers. So that's g of s. Now we're in factored form. We can set g of s equal to 0 to solve for our variable s. From here, we can use the zero product property and say that, well, s minus 10 equals 0, and also s plus 3 equals 0. For this one, I can add 10 to both sides to give me x equals 10. And for this one, I can subtract 3 from both sides to give me s equals -3. So those are my x-intercepts. That is where the parabola is going to cross the x-axis at x equals -3 and x equals 10, or s equals 10 rather. All right, let's look at this one. So this one we don't have to do any work. It's already factored for us. You see these parentheses right here, they don't have any signs in here, like a plus or a minus sign. So that's multiplication. We have multiplication of two things, which means that we can use the zero product property to find our zeros. So we don't have a lot of work to do here. First thing, since it's already factored, we can go ahead and set y equal to 0. And from here, I can set each individual factor equal to 0. So I get 2x minus 5 equals 0, and I have x plus 4 equals 0. So to solve for x, I'll first add 5 to both sides, and I get 2x equals 5, and then I'll divide both sides by 2 to give me x equals 5 over 2. Over here, I simply subtract 4 on both sides to give me x equals -4. And so 5 over 2 and x equals -4 are zeros. And again, we can always plug in any of these equations in standard, factored, or vertex form into Desmos to check ourselves. So I want to do that for this last one. Okay, so there's our parabola, And if we click on the zeros there, we can see that indeed we do get zeros at -4 and 5/2, which is the same thing as 2.5. So that's how you can check yourself when you're doing your homework. All right, what numbers are a solution to, I should have had an equals 0 here. So what numbers are a solution to this equation? So we're basically trying to first factor it if we can and solve for x. Now it's already set equal to 0, so we're in a good position to start factoring. Before you factor, you always want to make sure one side is equal to 0, okay? Because if it's not, it doesn't really make sense. We'll get more into that in a few slides, but let's try to factor this. So our c is going to be -7 and our b is going to be +6. So what two numbers multiply to -7 but add to +6? How about +7 and -1? So x +7 and x -1 equals 0, right? +7 times -1 is -7, and +7 plus -1 is +6. Excellent. So now that we set each of these factors equal, or now that we have everything factored, we'll set each factor equal to 0 independently and solve for x. So on the left side, subtracting 7 from both sides, I get x equals -7. And adding 1 on both sides to the other equation, I get x equals +1. So these are my solutions. In this case, they're the zeros as well. And going back to what we learned in the very beginning, what this means is if you plug in -7 into our equation, and if you plug in 1 into our equation, we're going to get a true solution. So these are our zeros and also our solutions here. Find the x and y intercepts of the function. So remember, x-intercepts are just zeros. That's all that means. So I'm going to do the y-intercept because that's the easiest. The y-intercept occurs when x is 0. So all we have to do is plug in 0 for x into our function up there and figure out what the output is. So let's do that. So we have 0 squared minus 2 times 0 minus 48, 0, 0, and we're left with minus 48. So this is our y-intercept. As an ordered pair, it's 0, -48 if you like that better. Now for our x-intercepts, we're trying to find the zeros. So we need to factor this first, okay? And then set it equal to 0. So what two numbers multiply to -48 but add to -2? I'm thinking -8, +6. So in factored form, this is going to be y equals x -8 x +6. All right. Now what we can do to get the zeros or the x-intercepts is we can set y equal to 0. And finally, we'll set each of these factors equal to 0. So x minus 8 equals 0 and x plus 6 equals 0. And now we'll just solve for x in both equations. Adding 8 to both sides in the first one, we get x equals 8. And subtracting 6 from both sides on the second one gives me x equals -6. So this is these are my x-intercepts. As an ordered pair, we have x equals 8, y equals 0, so 8, 0. And this one would be x equals -6, y equals 0. Again, for the y-intercept, x is equal to 0 and y is equal to -48. And again, we can use Desmos to check ourselves. So if I put this function into Desmos, x squared minus 2x minus 48, we get, indeed, we get x, one of our x-intercepts is -6, one of our x-intercepts is 8, and if we look to see where it crosses the y-axis, if I zoom out a little bit and click on it, we can see that it does cross the y-axis at -48, so we can confirm that our algebra is right. Okay. Find the zeros of the quadratic equation by taking square roots. So this is in vertex form, right? It's not in standard, so we can't really factor it from here. And we don't need to, because in vertex form, we can just take square roots of both sides to isolate our variable x. So first thing is, what does a 0 mean? It means when y is equal to 0. So my setup is going to look like this. I'm going to set y equal to 0, and I have 2 times x minus 4 squared minus 1. So we can just solve this equation. We don't have to factor out anything or anything like that. This is pretty nice, because remember how we solve equations? We're trying to get x by itself, and we want to undo the operations, quote unquote, away from x first. So the first thing I would do is I would add 1 to both sides to undo subtraction of 1. When I do that, I get 1 on the left, and then I get 2 times x minus 4 squared on the right. The next operation that needs to go is multiplication by 2. That's on the outside of what's happening to x. So to get rid of that, I can divide both sides by 2. And on the left, I'm left with 1 over 2 equals x minus 4 squared. So I see an operation of squaring on the outside of the parentheses, so I need to get rid of that. Now when I take the square root of both sides to undo a square, I need to make sure that I tack on a plus or minus sign on the left side, right? I'm taking plus or minus, and so this goes away. And on the left side, I'm left with plus or minus the square root of 1 over 2 equals, on the right side, the square root canceled the square, so I'm just left with x minus 4. And finally, I'll add 4 to both sides to give me x equals, maybe I'll write it over down here because I'm running out of room. So I have plus or minus square root of 1 over 2 plus 4 on the outside equals x. And so those are my two solutions. The first one is x equals positive root 1 over 2 plus 4. And the second one is x equals negative square root of 1 over 2 plus 4. So those are my two solutions. That's where this thing is going to cross the x-axis. Find the zeros by taking square roots. So again, we're in vertex form, which is really nice. And so since f of x is my y value, I'm going to start by setting that equal to 0. And maybe I'll just move this to the middle so I have more room. Okay, so I want to get x alone. I'm going to start by undoing the furthest operation, which is addition by 6. I'm going to subtract 6 on both sides. When I do that, I get negative 6 on the left equals negative 3 times x plus 8 squared on the right. Okay. Now what I want to do is undo multiplication by negative 3 by dividing both sides by negative 3. And when I do that on the left, I get positive 2, and on the right, I'm left with x plus 8 squared. Now to undo that square, I need to square root both sides, keeping in mind that when I take the square root, I need to tack on a plus or minus sign. That goes away, and on the right, I'm just left with x plus 8. And on the left, I'm left with plus or minus root 2. Finally, I'll subtract 8 from both sides to get x alone. And I'm left with plus or minus the square root of 2 minus 8. So these are my two zeros. The positive square root of 2 minus 8 and the negative square root of 2 minus 8. Those are the places where this quadratic is going to cross the x-axis. Okay, so we are going to learn one final technique for finding zeros that isn't factoring or taking square roots. It's something called the quadratic formula. And we use the quadratic formula if it's not easy to factor a quadratic in standard form, or if we don't have vertex form. So this is the quadratic formula. Now, in order to use it, very important that this must equal 0. You must have one side equaling 0 because, again, it's just, we're finding the zeros. We're trying to figure out what x is when y is 0. So we want to make sure that's 0 first. And then the formula itself is right here. So x represents the zeros. So x is the zeros, and all of these letters that we see are the letters in standard form. So we're going to do a bunch of examples so you guys get the hang of it. So the first example I'm going to look at is this one right here. Find the zeros. Now notice that if you try to figure out a number that multiplies to 1 and adds to -5, you can't really find that very easily. So in that case, we have to employ a different method. In this case, the quadratic formula. So notice that we have A, B's, and C's to deal with. So I want to start by looking at my standard form and identifying what A is, what B is, and what C is. So in our case, we can see that the coefficient of x squared is 1, and therefore A is 1. B is the coefficient of x, which in our case is -5. And C is the constant at the end, which is +1. Now that we have these three numbers, all we have to do is plug this into the formula for each letter. When we see a letter, we replace it with its corresponding number. And then we can simplify it and clean it up a little bit. So what we have when I do that, -b, I have the negative's already in the formula, so I want to make sure that's left alone. And I'm plugging in -5 in for b. So I have these double negatives basically. And then that's going to be plus or minus the square root of b, which is -5, squared, minus 4 times a, which is 1, times c, which is also 1. And this is all divided by 2 times a, which is 1. So let me do this. Let's do b's in blue. Let's do a's in green and c in purple. So I'm just going to show you where I plugged everything into the formula. So here's my b in blue, my a in green, and we have an a on the bottom as well. And then my C is in purple. So I just plugged in those numbers for the letters in the formula. And from here I can simplify. The first thing I notice is on the outside, these double negatives make a +5, so I can clean that up. On the inside, -5 squared is 25. And -4 times 1 times 1, -4 times 1 times 1, is -4. On the bottom, 2 times 1 is 2. Under the radical, 25 minus 4 is 21. Yeah, took me way too long to do that. Alright, so that's it. That's all we can simplify. So if you were writing this like two separate solutions, the first solution would be x equals 5 plus the square root of 21 all over 2. And the second solution would be x equals 5 minus the square root of 21 all over 2. So these are my zeros. These are my solutions to this equation. It's where it crosses the x-axis. Okay, let's try another one. Now, looking at this one, notice that we have an issue right here. Now, I'm going to show you something wrong that a lot of students do, and I don't want you to make the same mistake. So what a lot of students would do is they would look at the left side and they would say, hey, I can factor that. What multiplies to 4 and adds to negative 5 is x minus 4 and x minus 1. And then we would have equals 8, and students would do this. They would say, well, x minus 4 equals 8, and x minus 1 equals 8. But that's not true. We can only do that when the right side is equal to 0. And, because it's saying, well, hey, this could be 8, or this could be 8, but what if those numbers are what if x minus 4 is 4? What if x minus 4 is 2? 8 has other factors other than 8. So, in conclusion, we can't do this unless the right side is equal to 0. Basically, long-winded explanation of that. So the first thing we need to do is we need to make one side equal to 0. And to do that, I'm going to just subtract 8 from both sides. Now, when I do that, I get x squared minus 5x. 4 minus 8 is going to give us negative 4, and that equals 0. So now I'm in a good position, but I can't factor this, right? What two numbers multiply to negative 4 but add to negative 5? I can't think of two off the top of my head. So what we're going to do is use the quadratic formula. And in this case, a is equal to 1, b is equal to negative 5, and c is equal to negative 4. So let me write this up here. A is 1, b is negative 5, and c is negative 4. And then we're just going to plug all of those values into this formula here. So we get our zeros equal negative b, again the negative 5, plus or minus the square root of b, negative 5 squared minus 4, I'm running out of room, times a times c. Just doing this in green so I don't run out of room. Alright, and then this is going to all be over 2 times a, so 2 times 1. Alright, let's clean it up a little bit. These double negatives in front can become a positive, and under the radical, negative 5 squared is 25. Negative 4 times 1 times negative 4. Negative 4 times 1 times negative 4 is a positive 16. Positive 16. All over 2. Alright, so cleaning it up even more, under the radical, 25 plus 16 is going to give us 40. All over 2. And that is going to be our answer here. Now, you can simplify this a little bit, and I want to show you how. I'm not gonna really bang on about this too much, but I do want to show you how we can simplify numbers under the radical. So the square root of 40, you want to find a number that is a perfect square number. So like, for example, 4 is a perfect square number because the square root of 4 is just a number 2. It's not a decimal. Or 9 is a perfect square number because the square root of 9 is 3. What's next? 4 squared is 16. 16 is a perfect square number. 5 squared is 25. 25 is a perfect square number. So you want to think about factors, numbers that multiply to 40 that are perfect square numbers. And what I'm thinking of 4. All right, I'm thinking of 4. So I know that 40 is the same thing as 4 times 10, right? No arguments there. And again, I chose that because 4 is a perfect square number. But what's cool here is that I can take the square root of 4 out. So the square root of 4 can come out. And when I take the square root of 4, that's 2. So this is just 2 root 10. I already took the square root of 4 out. It was 2. And so the square root of 40 is simply 2 root 10. which means that this expression right here can be fully simplified by writing 5 plus or minus. Instead of root 40, we can replace it with 2 root 10, and that's all over 2. So this would actually be a better answer. This is a more simplified answer. And we're going to do some more examples. Well, maybe I'll do another example here just to show you what's going on. So the square root of 27, think of a perfect square number that can divide it evenly. Well, it's going to be 9. 9's a nice number that does that. So the square root of 27 is the same thing as 9 times 3. And what's the square root of 9? It's 3. So we can pull it out and leave that other 3 behind. So the square root of 27 is equal to 3 square roots of 3. One more example and then I'll stop. How about the square root of 160? Well, this right off the bat is 16 times 10. I can see that. So I do the square root of 16 times 10. Now what's the square root of 16? It's 4, so I can pull it out, and then 10's left on the inside. So the square root of 160 is 4 square roots of 10. Alright, sweet. That was a little side lesson. Hopefully that made sense to you guys, but that's how we can simplify radicals. So let's look at number 2. We're in standard form. We want to solve this, so we want to find the zeros. Now, I can't factor this. I'm trying to think of numbers that multiply to 1, yet add to -5, and I can't think of anything. So in that case, I'm going to use the quadratic formula. Now, in our case, A is equal to 1, B is equal to -5, and C is equal to 1 as well. So our quadratic formula is -b plus or minus square root b squared minus 4ac, all divided by 2a. And I'm just going to replace in these numbers as I see them here. So we have x equals -b, again a double -5, plus or minus the square root of b squared, -5 squared, minus 4 times a is 1, times c is 1, all over 2 times a. Alright, so cleaning it up, on the outside those double negatives can become a positive 5. On the inside, -5 squared is 25. -4 times positive 1 times positive 1 is -4. All over 2 times 1 is 2. And we get x is equal to 5 plus or minus the square root of 21 all over 2. So those are my two solutions. Did we already do that? 5 minus square root of 21? Yeah, we sure did. Wow. Okay, we already did that problem. Awkward. Okay, let's do this one. So I encourage you to pause the video, see if you can do this one yourself. So again, guys, what we're trying to do is we're trying to find the zeros with the quadratic formula. We're trying to figure out where this thing crosses the x-axis. Okay, that's what the finding the zeros is about. So let's go ahead and figure out what a, b, and c are in this. So here we can see our coefficient of x squared is 1, so that's a. The number in front of x is 6, so that's b. And c is going to be 2. And using the quadratic formula right here, we have -b on the outside, so -6 on the outside, plus or minus the square root of 6 squared, right, that's b squared, minus 4 times a, which is 1, times c, which is positive 2. And that's all going to be divided by 2a, 2 times 1. Let's clean it up. On the outside, we can't clean that up. But on the inside, if I take the square root of 6 squared is 36. Now, -4 times positive 1 times positive 2 gives me a net result of -8. -4 times positive 1 times positive 2. And this is all over 2 times 1 is 2. 36 minus 10 is 26, so 36 minus 8 must be 27, 28. So this is going to be x equals negative 6 plus or minus the square root of 28, all divided by 2. Now this guy can be simplified, so I'm going to do that off to the side. Can you think of a nice perfect square number that divides 28? Well, I'm thinking of 4. So I know 28 is 4 times 7. And I know what the square root of 4 is, it's 2. So this becomes 2, leave the 7 on the inside of the house. So the square root of 28 is the same thing as 2 square roots of 7. So I'm just going to replace that here. We have x equals negative 6 plus or minus 2 square root of 7 all over 2. I'm going to separate my answers out here and we can simplify even further. I'm going to show you how. So our first answer is negative 6 plus 2 root 7 over 2. And we're going to simplify that in a second. And then our second answer is negative 6 minus 2 root 7 all over 2. So looking at this, we can simplify this, and that's because we have 3 terms all divisible by a common number. All of these numbers can be divided by 2. If I divide negative 6 by 2 on top, I get negative 3. If I divide 2 root 7 by 2, I'm just left with 1 root 7. So this is just going to be plus 1 root 7. Over, well, 2 divided by 2 is 1, so I don't even have to write that. So this is my first solution here, and I can do the same thing for this guy. All 3 of these guys are divisible by 2. So negative 6 divided by 2 is negative 3, negative 2 divided by 2 is negative 1, and 2 divided by 2 on the bottom is 1. So my 2 solutions are x equals negative 3 plus root 7 and x equals negative 3 minus root 7. That is where this graph, when you put it in Desmos, is going to cross the x-axis. Now when you put it in Desmos, it's going to give you a decimal, but you can simply put these 2 numbers in your calculator to get the decimal equivalent. So let me show you what I mean. So we have x squared plus 6x plus 2, x squared plus 6x plus 2. Alright, so I see my decimals here, for my zeros, I have negative 5.646 and negative 0.354. Now, if I take my answers that I got, let's see, the first answer I got was negative 3 plus root 7. Let's put it in. Negative 3 plus, oops, where's that square root? Negative 0.35, which corresponds to the rightmost 0. And then we have negative 3 minus square root of 7, which is negative 5.6 blah blah blah, which corresponds to the leftmost 0. Alright, so that was that. Let's try this one. Now first thing you want to do is make sure that one side equals 0 before you use the quadratic formula. That's what this is all about. So I'm going to start this by subtracting 9 from both sides. And when I do that on the left side, I'm left with x squared minus 7x minus 8. And on the right side, I'm left with 0, which is what I wanted. Now, you always want to do the easiest thing for you. If factoring is going to be easier for you and you can factor, go ahead and factor. If the quadratic formula is easier for you, go ahead and use it. You're going to get the same answer no matter what method you do. But here I notice that I can factor this, and for me it's easier to factor than using the quadratic formula. So what I'm noticing is that I can find 2 numbers that multiply to negative 8 yet add to negative 7. And those 2 numbers are negative 8 and positive 1. Again, I'm not going to use the quadratic formula for this one because I thought factoring was easier, but you should confirm that the quadratic formula is going to give us the same answer. And maybe I'll actually, well, yeah, maybe we'll do it. Setting each of these terms equal to 0, I get x minus 8 equals 0 and x plus 1 equals 0. So I get that my x-intercepts are x equals 8 and x equals negative 1. Now let's use the quadratic formula. In this case, a is 1, b is negative 7, and c, right, we're using this version, the version that's equal to 0. C is going to be negative 8. Okay. Now our quadratic formula says negative b, which is negative 7, plus or minus the square root of b squared, minus 4 times a times c, all divided by 2a. Cleaning this up on the outside, these double negatives make a positive. And on the inside, negative 7 squared is 49. Negative 4 times positive 1 times negative 8 gives me a net result of a positive 32. And this is all over 2 times 1, which is 2. Now 49, oh, why did that turn orange? Weird. Okay. 49 plus 32 is going to give us 81. Now we know what the square root of 81 is. The square root of 81 is 9. So I can replace square root of 81 with 9. And so I have two answers. I have x equals 7 plus 9 over 2, and I have x equals 7 minus 9 over 2. Now 7 plus 9 over 2 is 16, so 16 over 2 gives me 8. Check. That was my first answer. And then the second one gives me negative 2 over 2, which is negative 1, and that was my second answer. Alright, so let's go ahead and do this. We have 40 and 10. I'm trying to think of two numbers that multiply to 40 but add to 10, and I can't really think of any numbers off the cuff. So let's go ahead and use the quadratic formula. So in this case, a is 1, b is negative 10, and c is negative 40. And I'm just going to replace all of these letters into this formula. So we have x is equal to negative b, so negative negative 10, plus or minus the square root of b squared, minus 4 times a times c. And this is all going to be divided by 2 times a. Okay. Cleaning up the outside, these double negatives can be reduced to a positive 10. And on the inside, negative 10 squared is 100. Negative 4 times positive 1 times negative 40 is positive 160. And that's all divided by 2 times 1 is 2. So we get x is equal to 10 plus or minus the square root. 100 plus 160 is 260, all divided by 2. I think I can simplify 260. I'm going to try by 16. Does 16 go into 260? Let's see. No. Let's try 4. Yeah, 4 times 65 is 260. So simplifying this is the same thing as 4 times 65. And the square root of 4 is 2, so I pull it out, leave the 65 on the inside. And 65 can be divided by 5. It's 5 times 13, but that can't be simplified anymore. So this is it. This is our square root of 260 is the same thing as 2 square roots of 65. So I'm going to replace it here. So I get x is equal to 10 plus or minus 2 square roots of 65 all over 2. And notice that I have 3 terms. All can be divided by 2. So 10 divided by 2 is 5. 2 root 65 divided by 2 is simply root 65. And 2 divided by 2, well, that's 1. So these are our zeros. 5 plus root 65 and 5 minus root 65. All right, let's go ahead and do this one. It's already set to 0, which is good, and we're in standard form on the right. So we have a is equal to 3, b is equal to negative 3, and c is equal to negative 8. And let's plug everything into our formula. So we have x is equal to negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Cleaning up the outside, these double negatives make a positive 3. On the inside, negative 3 squared is a positive 9. A negative 4 times a positive 3 times a negative 8 is going to be what? Negative 4, positive 3, negative 8 is going to be a positive 96. All over 2 times 3 is 6. Now 96 plus 9 is going to be 105. Can 105 be simplified? I don't think so, no. So we're going to leave it like this. So these are my 2 zeros. All right, let's do this one. All right, first thing I want to do is make sure one side equals 0. So I'm going to start by adding 1 to both sides to do that. When I do that, I get 2x squared minus x. Negative 5 and 1 make a negative 4, and that equals 0. So now I'm in a good position. So now that it equals 0, I can say a is equal to 2, b is equal to negative 1, and c is equal to negative 4. From here, I can just plug in my values into my quadratic formula to get my zeros. So I have x equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Cleaning up the outside, I get a positive 1 right there. On the inside, negative 1 squared is 1. Negative 4 times positive 2 times negative 4 is going to be a positive 32. And that's all over 2 times 2 is 4. Finally, on the inside of the radical, 1 and 32 make 33, which can't be simplified. All over 4. And those are my zeros. Let's try this one. So it's in standard form. Let's have it equal 0 first. So now that it's set equal to 0, we can say, well, a is going to be 4, b is going to be positive 3, and c is going to be 8. Plugging everything into my formula, I get negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Alright, so simplifying under the radical, 3 squared is 9. Negative 4 times positive 8 is negative 128. And then on the bottom, 2 times 4 is 8. Now 9 minus 128 equals negative 119. Okay, so something is wrong here. Notice that there's a negative under the radical. Okay, so negatives under the radical are not allowed, right? And what does this translate to graphically? What does this mean? So first of all, what we're going to say is that there are no real zeros. Now there are imaginary zeros, but that's a topic for another day. But there are no real zeros because of this negative under the radical. Now what does this translate to graphically? What do you think that means? Well, that means the graph isn't going to cross the x-axis. That's what that means. So if we were to plug this thing in Desmos, 4x squared plus 3x plus 8, it never crosses the x-axis. All right? So no real zeros. That's our answer, no real zeros. Let's try this one. So we're in standard form, we're set equal to 0, we're in a good position. In this case, A is equal to 3, B is equal to -5, and C is equal to -1. Plugging these values into our quadratic formula, we get x is equal to -b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Okay, so on the outside, those double negatives make a +5 plus or minus. On the inside, -5 squared is 25. -4 times +3 times -1 is a +12. And this is all over 6. Okay, so we get x is equal to 5 plus or minus the square root of 37 all over 6. And those are our answers. All right, so let's talk about some application problems. There's some really cool application problems that you can do with quadratics. So let's get right into it. It says at time 0 in seconds, a pair of sunglasses is thrown off the Eiffel Tower in Paris. At time t, its height above the ground can be modeled by this function. H of t is equal to -16t squared plus 900. So the first part of this question says, what does the expression tell us about the height from which the sunglasses were dropped? Well, at time 0, it's, the sunglasses are at the height that they're dropped, right? So what we're trying to figure out is what is the height when time equals 0, aka what is h of 0? So when we plug in 0 for t, time, we get -16 times 0 squared plus 900, and that -16 times 0 clears, and we're just left with 900 feet. So we know that it starts at 900 feet. When do the sunglasses hit the ground? Well, what that translates to is the height being 0. So we want to set h of t equal to 0 this time. So this is going to be 0, h of t, and we're trying to figure out the time that occurs. So we're looking for t. Okay. Now notice that I have only 2 terms here, and so that means I don't have to factor anything. I can just solve by using square roots. So to first do that, I'm going to subtract 900 from both sides to give me -900 equals -16t squared. And then I'm going to divide both sides by -16 to isolate the t squared. And let's see what that gives us. It's going to give me 56.25 equals t squared. And the last thing I need to do is take the square root of both sides, tacking on a plus or minus. But we're going to throw away the minus because we're talking about a real world situation where we're looking for time, and time can't be negative. So on the right, we're left with t, and on the left, we want the square root of 56.25, which is going to give me 7.5, and this is in seconds. So 7.5 seconds, the sunglasses are going to hit the ground. Okay, you hit a baseball in the air. The height in feet of the baseball t seconds after it's hit is given by this height function. H of t is equal to negative 16t squared plus 96t plus 4. So the first thing is, what is the maximum height of the baseball? Now we know this is a quadratic because of the square on the variable. That's the highest power. So it's going to look something like this. It's going to be an upside down parabola because of this negative. That's our a value. And so what we're looking for is right here. We're looking for the maximum height, aka the vertex. And we know how to find the vertex. Graphically, we just put it in Desmos. Algebraically, we can say, well, the vertex is going to be, it's going to be h comma k, and h is negative b over 2a. In this case, b is 16. So we have, b is 96. So we have negative 96 over 2 times negative 16. And that's going to give us 3. So h is 3. And now we need k. So k we can find by just plugging 3 into the function for t. That's our output. So we have negative 16 times 3 squared plus 96 times 3 plus 4. All right. So let's go ahead and compute this. All right, so I'm getting k is equal to 148. So my vertex is going to be 3, 148. And keep in mind what the variables mean. The first variable is time, that's our input. The second variable in an ordered pair, in this case, is our height, which is the output. And that's in feet. Yes, it's in feet. So, since it's asking the maximum height, this is the height, right? That's the part of the ordered pair that's the height. So our answer is 148 feet. And it says, what time does this occur? Well, the corresponding time is going to be our h value, which is 3, at 3 seconds. So that's our answer. Okay. All right, your backyard borders a river. You buy 80 meters of fencing. What dimensions maximize the area of your backyard? So let's draw a little picture. We have our backyard here, and it borders some kind of river. And so in black, that's our fencing. We have 80 meters of it. These two widths right here that I'm bolding, we could call these X. We're not really sure what those dimensions are. And we could call the longer one Y. And what we do know is that we have 80 meters of fencing to use around the perimeter. So I can come up with an equation to model this. So I can say, well, when I add up all of the sides of this fence, x plus y, that should give me 80 meters, right? So combining like terms on the left, x plus x is 2x. And what I'm going to do to set this up is I'm going to isolate for y, because I'm also going to use an area function. So this is the perimeter function that I was given. I know that I have 80 meters of fence to use along the whole perimeter of my backyard. And so I set up an equation using that information. If I subtract 2x from both sides right here, I get that y is equal to 80 minus 2x. So I'm going to keep that information in the back of my pocket because I still don't know what x and y are. All right. So that's my perimeter function. Now the function that I really care about is the area function. and I want to maximize the area function. So the area of a rectangle is length times width. In this case, the area of the rectangle is going to be x times y. All right. And I isolated y so that I could plug in something in terms of x for it. Okay, so that I can have a function in one variable. Now y is equal to 80 minus 2x, so I'm going to plug that in for y up there. I can distribute that x in there, and I'm left with 80x minus 2x squared. Well, this is kind of cool, right? Because this is the area, right? So if I plug in an x value, a dimension for this fence, I get out a corresponding area. And the question is, what do the dimensions need to be to maximize this area? All right. So what we can do is we can actually look at this on Desmos. We're going to find the maximum. That's going to be the tip of the parabola. So 80x minus 2x squared. 80x minus 2x squared. All right, so let's zoom out a little bit. So here's my area function. It's a parabola, and the maximum area occurs. So the area is the output. So the maximum area is 800. And that occurs when x is equal to 20. Let's write that down. The maximum area is 800, right? It was 800. And occurs at x equals 20. Cool. We just found x, which was one of our dimensions. So x equals 20, that's part of our question. What do the dimensions need to be? But we also want the dimension y. And so to figure that out, I can just use this nice area formula. We just found out that when the area is equal to 800, x is equal to 20. So using this area formula, a equals x times y, I get 800 equals 20 times y, and I can solve for y this way. So dividing both sides by 20, I get 40, yeah. So I get y equals 40, and so that is my missing dimension here. So my answer, the dimensions that maximize my backyard, is going to be 20 by 40. And that's my answer.